Good morning, guys. So we're going to start with a basic idea today on the topic matter. Matter is anything that occupies space and has mass. It's anything around us. It may not necessarily be something that we see. It could be in the form of solid, liquid, gas, or plasma. Let me just turn off my video. And let's move on to the next idea. Elements. So you'll see here the picture of the periodic table of elements. We have so many of them. And how is it related to matter? Any matter, be it solid, liquid, gas, or plasma, is made up of elements. It may be made up of more than one element, or it may just be made up of one element. Each element is made up of an atom. This is a picture of the oxygen atom. So for example, if the name of the element is oxygen, the name of its atom is called oxygen atom. I'm going to go back to the periodic table here. You will see each element has a symbol and they all start with a capital letter. So either it will have one letter or two letters. So over here, you have a capital H. This one, lithium, is capital L and lowercase I. So you will know that the L and the I are together because the second letter is lowercase. Cobalt is a capital C and a lowercase o. So that's the symbol for cobalt. How different is the cobalt with carbon? They both have the C, but carbon is letter C by itself. So that's how we name or how we put the symbol for each element. So elements cannot be broken down anymore because that's the smallest part. If you break them down further, the only thing you're going to see are the particles of an atom, which are the electron, the proton, the neutron, and the nucleus, which we will not really cover for this course. It's going to be under your chemistry. Because this is living environment, let's focus on the elements that are found in living things. There are 25 elements found in the living body, and you need to focus on the 6 of them. The C, carbon, H, hydrogen, O, oxygen, N, nitrogen, P, phosphorus, and S, sulfur. Summary, just say CHNOPS, okay? CHNOPS are the 6 most common elements in the body. However, 97% of the body mass is made of CHON. Look at the graph here. Oxygen makes up 65% of our body. Carbon is 18%, hydrogen is 10%, nitrogen is 3%, calcium 2%, and all the other elements not specified anymore is 2%. Elements do combine, and when they combine, they form a compound. So for example, in this picture here, you're going to see an oxygen, the red, combining with 2H. Together, they form H2O. H2O is the chemical formula for water. When elements combine, they form a compound. You need to know the 2 types of compounds in this course. You have organic and inorganic. Organic are made or contain both the elements C, carbon, and the H, hydrogen. On the other hand, inorganic may contain either C or H or neither of them. Let's look at the diagram here. Just looking at the molecular formula, I can see the C, carbon, and the H. Because they're together here in this molecular formula, it's classified as organic. On the other hand, over here, I can clearly see that there's an H. And over here, it may look like a carbon, but if you look at the second letter, it's a lowercase, so it's Cl. It's not carbon, it's chlorine. So there is the C, there's the H, but there's no carbon. That makes it inorganic. So let's check what you have learned. I'm going to pause and I want you to think as we pause and then say your answer and let's see if you're right. So there are two types of compounds, organic and inorganic. Organic compounds contain both the elements C, carbon, and H, hydrogen. Inorganic compounds may contain either C or H, or neither C nor H. Let's do the first example. Again, I'm going to pause. I want you to think and give your answer. This molecular formula shows you a carbon combined with two oxygen. Together, it's called carbon dioxide. Carbon dioxide. Di means two. Pause. Is this organic or inorganic? That's right. It's inorganic because there's no H, only C is present. Second example, you have Na sodium combined with Cl chlorine. Together, it's called sodium chloride. Sodium chloride is the formula for salt. Is this organic or inorganic? Pause. That's right. It's inorganic. There is no C, so neither C nor H. Third example. I have an O combined with two H's. Together it's called H2O. H2O, otherwise known as water. Is this organic or inorganic? That's right. It's inorganic because it only contains H, but there's no C. Last example, we have sucrose. Sucrose is a type of sugar. How would you know it's a name of a sugar? Okay, because it ends with OSE. Another example is glucose. You will be hearing this a lot in this course. Glucose, sucrose, fructose. Okay, just look at the chemical formula. Look for the two key elements, the carbon and the hydrogen. Is this organic or inorganic? That's right. This is organic because you have here the C and the H together. Okay. We're going to have an additional information on this one in the lab. The lab will not be tomorrow. We will have to decide next week as to when we're going to do the lab. But this is an information on chromatography. Chromatography from the chroma from the word chroma means color. So chromatography is when we separate the components of a liquid mixture. And as they separate by splitting colors. And there are many different ways of physically separating mixtures. By the way, compounds like water, we cannot physically separate them. Mixtures we can. So chromatography is for physical separation of mixture. So there are other ways of physically separating mixtures like use a filter paper. We call that filtration. Or you can use a magnet to separate a metal from a non-metal. Or you can use your hand, separate the different materials. We call that manual separation. Now, this chromatography uses a special paper called chromatography paper. There you go. That's the white thing, rectangular white. This dot here is the mixture from the source, from the main source. It could be an organism, it could be a chemical. And this blue part here is the water. This is the beaker. Or it could be any container. It could be a test tube. It could be a cylinder. Now, the top here is a cover. We only cover the container if it's a strong solvent. This one was covered. So we will assume this is not just water. This could be an alcohol. So we only cover the container if it's a strong solvent. However, if it's just plain water, there's no need for a cover. Pay attention also to where the dot is. The dot is above the water because if it's under the water, it will just be washed off. So it needs to be above the water. So as the water diffuses up, the mixture will separate into different colors, as you can see here. If you are comparing two different organisms, the two related organisms or similar organism should have the same chromatography result. And this is how we use chromatography. So we will end our presentation here, and you will use this information in understanding species X.